Time to do some coding here, and this is just the overall view of the binary search. Basically the code that we set up and call the binary search, check whether what we're looking for is in the list, and then we get back a result. If it's -1, we didn't find it, or if we got back something else, well, we must have found it wherever the middle item was, and we found it at whatever index position. So it looks a bit of a mouthful, but let's break it down a bit, decompose it, and have a look at what's going on in here. If I can get in and do it. So the first thing you want to do is you want to create your list. Make sure that it's an ordered list, or if it's not, that's the first thing you must do, is go and change it to an ordered list or sorted list after that. Then you want to initialize your search item, so get the user to enter a target value that you want to try and find in the list, and then we're going to call a function called binary search. We're going to pass it two things. The two things we're going to pass it is the list that we've created, see up there, my list created, and the search item that we want to try and find. Now, something is going to be returned from the function, and when it is returned, we're going to store it in this variable here called result, which we'll see in a moment. So here is the function binary search, and we've passed it my list, which I've now called list in. So the list that I'm receiving, so it's a generalization, and the search item that we're looking for, I've called it key here. So the key that we want to find. So like our algorithm or our pseudocode, set low to 0. Now this will be the first time you come in here, set low to 0 and set high to the length of whatever the list is, list in this case, -1. So that's going to be, depending if you have 7 things in the list, low will be 0 and high will be index 6, I think. 7 minus 1 is 6, and so on and so forth. So set high to the index of the last element. Then you're going to have this while loop here, and the reason that this is needed is basically while low is less than or equal to high. Well, while that is the case, you want to keep checking your data sets, getting your middle items. So basically you're ensuring that nothing is crossed over here and that you have no more things to check. So once that is true, you're going to go in and you're going to set your middle item to your low plus high, low index plus high index of the data set, floor division 2. So to find the index of the middle value. So when you found the middle value, then you're going to do your check of the middle value, the index that created at the middle value against your search item or your key. So basically it's a little if statement here, and the first thing you're going to do is you're going to check out of the same. So if the value located at the mid position is the same as the target value, return the index of that middle value. So if the list in, if the value located at the middle of the list is equal to what you're looking for, return the index of where it is. So you found it, return the index in the middle item. If it's not, you move on, you do another check, you say else if the value at the middle position is lower than the target value. So if it's lower, you want to cut off the data set to the right of the middle value, or sorry, to the left of the middle value, and then you want to go and set low to the mid plus 1. So else in is if the middle value in the list is lower than what you're looking for, you want to cut off that first half and set low to mid plus 1. And finally, well, if that's not the case, it must be that the value at the mid position is higher than the target value. So you want to cut off the first half of the list, and you want to set high, or sorry, cut off the second half of the list, and you want to set high to mid -1. So high equals mid -1. And go on to number 5 here, and as long as low doesn't cross over high, go back to step 3 above. So obviously if you've gone in here and you've returned the mid, you're going to get out straight away, that's it, done. But if you're doing one of these, you're then going to do this check, low is less than or equal to high. If it still is, if they haven't crossed over, well, you're going to go back in and repeat the process again. Now if it's the case that you get to the end of the while loop and finally low is not less than or equal to high anymore, so you must have got to the end of your list, have crossed over, you're going to return, you break out of the while loop, so that's going to be false, break out of it, and you're going to return -1 if the element is not in the list. So that's all good and well there. So we're going to move on now and see what we do when we get back our returned item from the function. So whatever is returned, we store it in a variable called result. And quite simply, we have a little if statement now. So if the result, if -1 happens to be returned, so if -1 is equal to -1 or equivalent to -1, then the search item is not found. The return value is -1. That was what the return value was. But if it's not equal to -1, well else the search item must have been found at index position result. So the middle value was returned from the list, stored in result, and therefore the search item, whatever you're looking for, was found at index position result. And there's the coding done for the binary search, and that's that.